Sorry. Okay. So what we will do, we will first go for generalized coordinate and generalized velocity. And then we will just try to learn little bit of calculus of variation, which is actually backbone of your classical mechanics. That is basically mathematical backbone of your classical mechanics. And then we will go for what? Hamilton's principle. And once we will do Hamilton's principle, then we will try to formulate Lagrangian. Okay. I request everyone to please mute yourself unless until you, जब तक आपको कुछ कहना नहीं हो, है ना? And I will give you sufficient time to discuss. Don't worry, है ना? Don't worry, क्योंकि बात करना मुझे भी अच्छा लगता है. Okay? चलिए. Great. So let's go for generalized coordinate and generalized velocity. So we are just going for generalized coordinate and generalized velocity. Okay. Okay. So in general, we will define generalized coordinate as some q or some qi if you have more than one generalized coordinate. So generalized coordinate can be represented by some q. So what is generalized coordinate? So generalized coordinates are dynamical variable. Generalized coordinate क्या होंगे? They are what? Dynamical variable. What is meaning of dynamical variable? Means dq upon dt will not be equal to 0. So they are what? Dynamical variable which explain independent motion of a system uniquely. वो क्या करेगा? इंडिपेंडेंट मोशन. कैसे मोशन की बात कर रहा है? इंडिपेंडेंट मोशन. And uniquely. These two words are very important. Now, what is meaning of independent motion? Means you need to work with the degree of freedom. Independent motion कौन explain करता है? That is all about degree of freedom. So you need independent those variable, those dynamical variable, which will explain the independent motion, and that variable will be uniquely defined independent motion. For example, suppose the particle is doing motion in a two-dimensional plane, and this motion is something like a spiral. Then what will happen? I can represent this motion in term of r and theta. Now, r and theta can be used as a generalized coordinate when it will discuss the independent motion, and that should be unique in nature. That means, yeah, first is r dot is not 0, so it is dynamical variable. So r dot or r will explain you how your particle is moving away or towards the origin. If this is my origin, are you getting my point? How it will go towards or away the origin at the particular value of theta. And what will be theta? At the particular value of r, how your particle is rotating about x-axis. Suppose it is my rotating about z-axis and reference is from x-axis. This is my y-axis and this will be my z-axis. So there are two independent motion. One is radial motion and another is angular motion. So we need two independent dynamical variable, and they will explain these two motion uniquely. Means r will only tell you about the radial motion. Uniquely, r will uniquely associated to the radial motion, and theta will also uniquely associated, and theta will uniquely associated with the angular motion. So they are independent, so they can be independently tell about the one particular unique motion. Are you getting this thing? So now, so most important thing is that if how would you check that whether it is dynamic, whether it is generalized coordinate or not? The most important thing is that number of generalized coordinate must be equal to number of DOF, isn't it? जब तक आपके number of dynamical variable, so number of dynamical variable, so you can write something like this, so that can be much better. Number of dynamical variable must be equal to number of degree of freedom, then this dynamical variable is known as what? Generalized coordinate. Are you getting my point? कि आपके
Yes,
पास
sir.
कितने नंबर ऑफ डिग्री ऑफ फ्रीडम है, ये आपको जब तक नहीं पता चलेगा तब तक आप ये डिसाइड नहीं कर सकते हो कि इस सिस्टम को एक्सप्लेन करने के लिए कितनी नंबर ऑफ जनरलाइज कोऑर्डिनेट चाहिए. आर यू गेटिंग माय पॉइंट?
Yes, sir.
Okay. And most important thing is that it is not necessary. It is not necessary that every generalized coordinate of a system, generalized coordinate of a system have same dimension. Have same dimension. It is not necessary that, as in configuration space, you will see that all generalized coordinate have dimension of meter per second. Velocity have dimension meter per second, or have every displacement is meter. No, in a same system, one generalized coordinate have displacement of length, another generalized coordinate have displacement of some angle, of a dimension of some angle. You can also think that your generalized coordinate is not associated to basically only one coordinate system also. It may be possible that in your system, you have one coordinate system is associated to the Cartesian one, or one generalized coordinate is associated to the Cartesian one, and the another generalized coordinate is associated to the polar. We can have this kind of situation. So it's a very, very wide thinking to solve the problem. You can just fix the origin, and once you will fix the origin, then obviously you can see the appropriate degree of, you can calculate appropriate degree of freedom, you can analyze the independent motion, and then accordingly to that, you can choose your generalized coordinate. So it's a very good thing, isn't it? अभी तक कुछ पूछना है तो पूछिए, then we will go for generalized velocity.
सर ये जो आपने डायनामिकल वेरिएबल या आपने एग्जांपल जो दिया था पार्टिकल स्पाइरल की फॉर्म में, अगर यहाँ पे आर हमारा फिक्स नहीं होता और वो ओरिजिन पे मतलब वो अंदर की तरफ भी आ जाता, तब वो डायनामिकल वेरिएबल से हम रिप्रेजेंट करते,
मतलब
आर
सॉरी,
अगर जीरो हो जाता, जैसे आपने अभी
आर अगर जीरो हो जाता, जस्ट अ मिनट,
जी।
आर अगर जीरो हो जाता तो आप एंगल कैसे मेजर करते?
हाँ मतलब वो डायनामिकल वेरिएबल तब नहीं हम रिप्रेजेंट कर पाते हैं.
आप इसको ऐसे कर सकते हो, आपका क्वेश्चन मैं रिफ्रेम करता हूं. आर की वैल्यू अगर मैं ए फिक्स कर देता, ठीक है, आर की वैल्यू अगर मैं ए फिक्स कर देता तो हमारा डायनामिकल वेरिएबल थीटा होता और वही जनरलाइज कोऑर्डिनेट होता.
हाँ मगर अगर इसमें अभी हम बाहर जा रहे हैं, वो स्पाइरल बाहर तक हो रहा है,
अंदर भी
मगर
जा
अगर वो
सकते हो,
inside
अंदर भी जा
होता,
सकते हो, बिल्कुल
और
अंदर भी
वो
जा
origin
सकते हो.
पे खत्म हो जाता.
हाँ खत्म तो हो जाता, दैट इज द टाइम एवोल्यूशन थिंग ना. वो तो कोई भी चीज खत्म हो ही सकता है, जहां पे डैम्पिंग होगी वहां खत्म हो जाएगा. व्हाट इज रॉन्ग इनटू दिस?
ओके
है ना, ऐसा कुछ नहीं है कि बाहर ही जाएगा, डोंट वरी, वो अंदर भी आ सकता है और एक समय आर की वैल्यू जीरो भी हो सकती है, डोंट वरी.
तो फिर वो dr/dt नॉट इक्वल टू जीरो नहीं हो जाता?
हो जाता है उस पर्टिकुलर टाइम पर, उससे क्या लेना देना, एक पर्टिकुलर टाइम पर हो ही सकता है dr अपॉन dt. मैं इन जनरल की बात कर रहा हूं. आर यू गेटिंग माय पॉइंट?
मतलब इस कंप्लीट मोशन में,
कंप्लीट मोशन में एक पर्टिकुलर पॉइंट पर आपकी वेलोसिटी जीरो हो सकती है, नहीं हो सकती क्या? इक्विलिब्रियम अचीव कर ले तो हो सकती है जीरो. ओके ओके.
सर
बोलिए।
सर
Yes.
जनरलाइज कोऑर्डिनेट का कॉन्सेप्ट ऑफ जो
क्या हुआ बताओ तो, क्वेश्चन नहीं आ रहा है मेरे पास।
सर कैन यू प्लीज एक्सप्लेन द कॉन्सेप्ट ऑफ जनरलाइज
वही तो
कोऑर्डिनेट?
एक्सप्लेन किया अभी, और क्या एक्सप्लेन किया?
सर dv इज इक्वल टू df।
db इज इक्वल टू df, ये क्या है? ये दिस वन,
आपने
नंबर ऑफ डायनेमिकल
yes, sir,
वेरिएबल,
yes, sir.
नंबर ऑफ डायनेमिकल वेरिएबल। आप कितने नंबर ऑफ डायनेमिकल वेरिएबल लोगे ताकि आप उसे जनरलाइज कोऑर्डिनेट कह सको? उसका कुछ तो टेस्टिंग होना चाहिए ना। सपोज करो कि
Okay,
आपके
sir.
पास 2 डिग्री ऑफ फ्रीडम है और आपने 3 डायनेमिकल वेरिएबल ले लिया, तो उसे आप जनरलाइज कोऑर्डिनेट नहीं कर सकते हो। आर यू गेटिंग माय पॉइंट?
Yes, sir.
है ना। अगर आपके पास 2 डिग्री ऑफ फ्रीडम है तो आपको 2 ही डायनेमिकल वेरिएबल होने चाहिए। आर यू गेटिंग माय पॉइंट?
Yes, sir.
हाँ, ऐसा नहीं हुआ कि आप आर्बिट्रली
Okay.
कुछ भी ले सकते हो। दिस इज वन ऑफ द टेस्टिंग टूल कि आप सही जा रहे हो या नहीं जा रहे हो। आर यू गेटिंग माय पॉइंट?
Yes, sir. Yes.
ओके। एंड दिस इज डायनेमिकल वेरिएबल, है ना। मैंने थोड़ा शॉर्टकट में लिखता हूं बिकॉज मेरे पास इतना स्पेस नहीं होता है ना। ओके, सो लेट्स गो फॉर जनरलाइज्ड वेलोसिटी।
सर सर जैसे अभी आपने बताया कि डायनेमिकल नंबर ऑफ डायनेमिकल वेरिएबल इज इक्वल्स टू नंबर ऑफ डिग्री ऑफ फ्रीडम, तो सर अगर ये कोऑर्डिनेट सिस्टम पे भी डिपेंड करेगा कि हम कौन सा चूज कर रहे हैं?
नहीं, डिग्री ऑफ फ्रीडम कोऑर्डिनेट सिस्टम पर नहीं डिपेंड करेगा,
सर
है ना। लेकिन समझने की कोशिश करो, डायनेमिकल वेरिएबल आपका नंबर ऑफ डिग्री ऑफ फ्रीडम के इक्वल होना चाहिए, लेकिन वो इंडिपेंडेंट मोशन को भी डिफाइन करे, ये भी तो इंपॉर्टेंट है।
यस सर।
तो सेम प्रॉब्लम को आप कार्टेशियन कोऑर्डिनेट में भी सॉल्व कर सकते हो, पोलर कोऑर्डिनेट में भी सॉल्व कर सकते हो, और आप सिलिंड्रिकल कोऑर्डिनेट में भी सॉल्व कर सकते हो। लेकिन
sir,
आपको
yes, sir.
हमेशा इंश्योर करना पड़ेगा कि जो भी आप डायनेमिकल वेरिएबल हो और नंबर ऑफ डिग्री ऑफ फ्रीडम पे डिपेंडेंट हो, के इक्वल हो,
Yes.
है ना। प्रॉब्लम करेंगे तो ज्यादा क्लियर होगा, डोंट वरी, ठीक है।
Yes, sir.
तो इसको एब्स्ट्रैक्टली मत देखो, जब हम प्रॉब्लम करेंगे तो आप ज्यादा बेटर ढंग से समझ पाओगे चीजों को। ओके
Yes, sir.
ओके, so let's go for what? Generalized velocity. So now look at the language. Language classical mechanics की बहुत ही ज्यादा इंपॉर्टेंट है, बिकॉज इसी लैंग्वेज के बेसिस पर जो कोरिलेशन है, इसी कोरिलेशन के बेसिस पर आप आगे जाकर के क्वांटम मैकेनिक्स को फॉर्मुलेट करते हो, ठीक है। सो नाउ लुक एट हियर, इफ qi is generalized coordinate, then qi dot, what is qi dot? dqi upon dt is generalized velocity conjugate to, ये वर्ड बहुत इंपॉर्टेंट है, conjugate to generalized velocity conjugate to generalized coordinate qi. So this is your generalized velocity. So आपको हमेशा conjugate की बात करनी पड़ेगी। Conjugate का मतलब क्या है कि first you have to identify what is your coordinate, and according to that you have to identify what is your velocity. Are you getting my point? So conjugate is very important. मैं आपको इस conjugate का थोड़ा सा glimpse देता हूं, आगे जाकर के कितना इंपॉर्टेंट होगा। If you are talking about uncertainty principle, तो हम लोगों ने सारे लोगों ने पढ़ा है ना। समझते हैं या नहीं समझते, बट हम लोगों ने पढ़ा है ना। सो अनसर्टेनिटी प्रिंसिपल में आप लेते हो डेल्टा एक्स इंटू डेल्टा पी एक्स, एंड दिस इज ग्रेटर देन एच कट बाई 2, इजंट इट? कुछ ऐसा होता है। नाउ इफ आई विल राइट डेल्टा एक्स इंटू डेल्टा पी वाई, is that this is true for the uncertainty principle?
No, sir.
No,
sir.
why
No,
not?
sir.
Because this py is not conjugate to x. Are you getting my
Yes,
point?
Yes.
So if you are talking about x, then the momentum associated to that x coordinate, because this x is itself a dynamical variable and dx upon dt is defined. So you can see this dx upon dt must be associated to this qi. So suppose you have x as your generalized coordinate, then its conjugate variable is very important. And suppose px में अभी कह रहा हूं, px को हटा देते हैं, अभी हम लोग बात करते हैं x dot, and x dot is what? Generalized velocity corresponding or conjugate to x. Suppose we are taking theta, then generalized velocity is what? Theta dot for the theta. ऐसा नहीं होगा कि x के लिए generalized velocity theta dot होगा, because it is defined something like dqi upon dt. And it is also important, it is very important thing that for a system, for a same system, it is not necessary all generalized velocity have dimension of meter per second. ऐसा कोई जरूरी नहीं है. It will depends on you कि आप क्या लेते हो generalized coordinate, उसकी dimension क्या है. Accordingly, you can just tell what will be your generalized velocity. For example, if your generalized coordinate has dimension of momentum, it may be possible. जो न्यूटोनियन मोमेंटम है उसी को आप जनरलाइज कोऑर्डिनेट कह रहे हो. अनफॉर्चुनेटली हमारी कोर्स उतना डीप रूटेड नहीं है, but in general you can take your momentum as your generalized coordinate, then what will be equivalent to generalized velocity?
Force.
Then dp upon dt, and which have two dimension of force. So this is your generalized velocity. Mind blowing thing कि आप मोमेंटम को कोऑर्डिनेट कह सकते हो और वेलोसिटी को और फोर्स को वेलोसिटी कह सकते हो, because it has all the property of generalized coordinate and generalized velocity. Similarly, you can choose generalized coordinate or angular momentum. Then what will be your generalized velocity? Obviously, dl upon dt. Then you can say torque is your generalized velocity. And this is a wonderful technique to make your calculation simple, make your calculation analytical, and you have to work and you have to juggle down with the mathematics. आपको just mathematics के साथ juggle करना है, and final outcome will give you all about your physics. Are you getting my point? है ना?
Yes, sir.
So these two things are very important. So don't try to just think like a Newtonian कि वहां पर x ही होगा, y ही होगा, ऐसा ही चीज हो सकता है. No, you have to be broad-minded, and anything can be your generalized coordinate, which will, and generalized velocity, which will going to satisfy these two relationship. Anything, any dynamical variable, don't worry. It may be that they don't have any dimension, isn't it? For example, generalized coordinate अगर आपका theta है, then theta is what? It is dimensionless, isn't it?
Yes, sir.
Yes, sir.
Then what will be your generalized velocity? Your generalized velocity is nothing d theta
Frequency.
upon dt, and this is nothing but a frequency. Okay,
Frequency.
that is nothing but the frequency. You can tell your frequency as your velocity. उसका हम बड़ा फेमस नाम देते हैं angular velocity, isn't it?
Yes, sir.
है ना? But actually that is frequency. 1 upon time is nothing but frequency. Okay? So हम लोग जैसे जैसे प्रॉब्लम करेंगे, we will get mature और उस चीज को उतने ब्यूटीफुली देखने की कोशिश करेंगे. So next I am just going to one particular mathematical technique, that is what known as calculus of variation. क्या mathematical technique है? Calculus of variation. उसे हम समझने की कोशिश करते हैं. Okay?
सर, ये जो चूज हम करेंगे जनरलाइज्ड कोऑर्डिनेट, वो यूनिक होगा ना?
एक मोशन के लिए यूनिक होगा. जैसे जो थीटा के लिए बात कर, जो
हाँ।
एंगल के लिए बात करेगा वो आर के लिए बात नहीं करेगा। ओके, चलो जब प्रॉब्लम करेंगे तो मैं आपको एक सारा चीज फिर से एक्सप्लेन करूंगा, डोंट वरी, है ना, जबकि जब तक आप अप्लाई नहीं करोगे उसको आप ऐसे ही डिस्कस करके नहीं समझ सकते हो। ठीक है, सो लेट्स फर्स्ट गो फॉर एप्लीकेशन पार्ट, देन वी विल एक दो प्रॉब्लम जैसे ही करने लगेंगे, एवरीथिंग विल बी ओके फॉर यू। ओके, so let's go for a wonderful mathematical technique, that is calculus of variation. This is wonderful technique and this is nothing but what? Calculus of variation. इस टेक्निक को थोड़ा हम समझने की कोशिश करते हैं। What is this particular technique? यहां तक क्लियर है ना? Let's say, let us go for any integral and this integral is some functional f as a y, and y can be function of x, y dot can be function of x, and x dx. And what is y dot? Here y dot is nothing but dy upon dx. यहाँ y dot को मैं क्या कह रहा हूं? dy upon dx. Suppose this is my functional and we can go from some limit x1 to x2, there is not any problem. And if this integral is extremum, suppose ये integral extremum होता है, extremum means what? It may be maximum, it may be minimum, and we are just talking about how you will get the maximum and minimum with the first order derivative, isn't it?
Yes, sir.
ऐसा ही तो करते हो, first order derivative. So I can go for first order derivative and I am just writing again, if I is extremum. Now if के बाद क्या आता है? इंग्लिश भी तो पढ़े होगे। then cause and effect. if है तभी then है, cause है तभी उसका effect है। This is all about Newton's law, isn't it?
Yes, sir.
जो भी cause है उसको आप effect के रूप में, acceleration के रूप में मेजर कर लेते हो, isn't it? सीखेंगे
Yes,
जब
sir.
हम इसके बाद जब न्यूटन्स लॉ करेंगे तो वहां सीखेंगे, डोंट वरी। इफ आई इज एक्सट्रीमम देन ऑब्वियसली del I must be equal to 0, then f as y dot x will follow Euler Lagrange's equation. वो क्या फॉलो करता है? Euler Lagrange's equation. What is this Euler Lagrange's equation? This is d upon dx del f upon del y dot minus del f upon del y is equal to 0. This is Euler Lagrange's equation. This is mathematical technique. So अगर आप मैथमेटिक्स से नेट देना चाहोगे, कभी दोगे, तो उसमें एक पूरा टॉपिक आता है, जैसे हमारे पास ईएमटी, क्वांटम मैकेनिक्स, अलग अलग टॉपिक्स है ना, वहां पर एक टॉपिक आता है कैलकुलस ऑफ वेरिएशन।
सर वो y डॉट है ना?
वाई
Del
डॉट,
F by
वाई डॉट, वाई डॉट, ये मैं तुम्हें इसका सिमेट्री सिखाऊंगा अभी, डोंट वरी। ठीक है, बहुत ही मजेदार है। आर यू गेटिंग माय पॉइंट? ओके, सो अब ये हमें यूज करना है टेक्निक, बट ऑब्वियसली यूज करने से पहले थोड़ा सा बिलीव कर लेते हैं कि ऐसा होगा कि नहीं। सो लेट्स गो फॉर वन प्रॉब्लम, हाउ टू यूज दिस पर्टिकुलर टेक्निक। एक प्रॉब्लम करके देखते हैं जिसका आंसर भी आपको पता है। सो डिलिबरेटली मैं वैसा प्रॉब्लम लिया हूं जिसका आंसर आपको पता है। व्हाट इज द शॉर्टेस्ट पाथ बिटवीन 2 पॉइंट इन अ प्लेन?
डिस्प्लेसमेंट
क्या होगा शॉर्टेस्ट पाथ? क्या? स्ट्रेट लाइन। एवरीवन नोस, आज से नहीं बचपन से पढ़ रहे हैं, है कि नहीं? Shortest distance is what? Straight line. Okay, let us try to go for this. Try to इसको हम लोग calculus of variation के साथ explain करके इसको समझने की कोशिश करता है। Okay, so suppose I have y versus x and my point can go to A to B. मेरा point A से B तक जा रहा है। So how many way we can go? We can go n number of way. So suppose I am choosing this path and this path is S. S कैसे मिलेगा? How you will get S? Integration over ds. Yes? ठीक है ना? अब इस ds के अंदर मैं छोटा सा पाथ लिया हूं ds. Suppose this is your ds. So मैं क्या कर रहा हूं? आपको जूम करके दिखा रहा हूं. This is your ds. And this is what? dx. And this will be what? dy. Are you people comfortable? So now, if ds is very small, you can assume this is a straight line, isn't it? So what we can have ds is equal to root under dx square plus dy square. Are you getting this thing? ds
Yes,
is
sir.
equal to root under dx square plus dy square. So what is this? S is nothing but root under dx square plus dy square. Clear है ये? ds is nothing, s is something root under dx square plus dy square. So what you will do? इसको मैं s ले लेता हूं. Can I take dx outside? So this will be 1 plus dy upon dx whole square dx. ऐसा कर सकते ना? And we will go from a to b. Don't worry. Can I write this thing? So this s have to be extremum. That means, and you can write this s equivalent to something 1 plus y dot square dx. लिख सकते हैं ना? Y dot is nothing but dy upon dx. Don't worry. Don't confuse with dy upon dt. So this is 1 plus y dot square dx. And now we have to just go for the extremum. So if it is extremum, then this value must be equal to 0. And then this function f will follow a Euler-Lagrange equation according to calculus of variation. Isn't it?
Yes, sir.
ये follow करेगा? Yes? Okay. So what we have? We have f we have defined, and this is 1 plus y dot square. Now this f will follow Euler-Lagrange's equation. ये f क्या follow करेगा? Euler-Lagrange's equation. Now what is del f upon del y? 0? Yes. And what will be del f upon del y dot? Y dot by root under 1 plus y dot square. सही है ना? Y square का 2 और root का half दोनों एक दूसरे को cancel कर दे रहे हैं. Are you people comfortable?
Yes, sir.
है ना? Now let's try to write Euler-Lagrange's equation. So this is d upon dt del f upon del y dot minus del f upon del y is equal to what? 0. होगा या नहीं? Yes? हाँ या ना? Okay. So this value is equal to 0. So you have,
0.
sorry, d upon dx. Sorry, not d upon dt, d upon dx. Extremely sorry. So d upon dx, del f upon del y dot minus del f upon del y is equal to 0. So what do you have? D upon dx, del f upon del y dot must be equal to what? 0. Means del f upon del y dot must be some constant. Let us, this constant is alpha. लिख सकते हैं? Just check it. कोई बहुत बड़ा कैलकुलेशन नहीं कर रहा है.
Yes, sir.
है
Yes,
ना?
sir.
So what will happen? This y dot by root under 1 plus y dot square is equal to alpha. So I can square both sides and I can take y dot common. So what will happen? This y dot square 1 minus alpha square is equal to alpha square. So y dot is equal to alpha by root under 1 minus alpha square, and which is also some constant. Constant by constant is constant. Let us say this constant is m. लिख सकते क्या? Yes या no?
Yes, sir.
लिख
Yes,
सकते हैं
sir.
ना?
Yes, sir.
So this constant is m. हाँ?
रूट में 1 प्लस y डॉट स्क्वायर था ना?
हाँ तो वही तो है, मैंने कुछ गड़बड़ किया है क्या? आप स्क्वायर करो, इसको इधर ले जाओ, फिर y डॉट को इधर लेके आओ.
ओके
कैलकुलेशन थोड़ा फास्ट करना होगा, है ना? So now this is my m. So what will happen? dy upon dx is equal to m, and that means y is equal to mx plus c. M and c can be determined from the initial condition and final condition, isn't it?
Yes, sir.
And what is this equation?
Straight line equation.
Straight line. यही तो पढ़े हो अभी से नहीं, क्लास 8 से पढ़े होगे, है ना? The shortest distance between 2 points is a straight line. So it is a very wonderful technique of the math, and this is typical mathematical technique. Don't worry. So this is a mathematical technique where you can just optimize any path, optimize any surface, optimize any shape, and you can use this calculus of variation. Now look at what we have done in a physics. So this is mother of all derivation, all philosophy behind the classical mechanics. So let's go for a first principle of the classical mechanics. Onto that principle, we will just try to define all our equation of motion, and we will try to define different type of formulation. So let us go for Hamilton's principle. Should I go for that?
Yes, sir.
Okay.
Yes, sir.
Okay, so let us go for Hamilton's principle. And this is very famously principle of least action. प्रिंसिपल का स्पेलिंग क्या होता है? जस्ट चेक इट. प्रिंसिपल ऑफ लीस्ट एक्शन. ओके, लीस्ट एक्शन है ना? प्रिंसिपल ऑफ लीस्ट एक्शन. ओके, look at the philosophical part. This is very interesting, and hold your breath. It is very important. Now what is going to happen? This is a particle. If I am going to throw this particle, this is my particle. If I am going to throw this particle, what will happen? This particle will follow some unique path. If all the environment and the initial condition are same. Are you people comfortable? Suppose
Yes,
I will throw this particle with some angle, with the same velocity, same condition, same angle, then every time it will follow the same trajectory, very famously known as what? Parabola. Isn't it? Projectile motion. है ना?
Yes, sir.
Now,
Yes, sir.
now try to think it philosophically. What is going to happen? Suppose I am just talking about y versus t. मैं one dimension motion की बात कर रहा हूं. I am just talking about y versus t. And I am just going to start from here, A to B. मैं कहां से कहां जा रहा हूं? I am just going to start from A to B. How many paths we can choose?
Infinite path.
Does that we can go from A to B? Infinite path. Infinite
Yes,
path.
sir.
You can go A to B from infinite path. Not one, not two, not three. You can go from A to B from infinite path. Everyone is comfortable? So if you will go to A to B from infinite path, and if infinite path is possible, then what will happen? At some t is equal to t, your particle can be there, 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 can be there. Is that possible into classical mechanics?
No, sir.
Never. Never. You will repeat this experiment again and again, again and again. Particle will follow the same path. Don't worry. It will always follow the same path. So, which path particle is going to choose? This is all about principle of least action. Okay. So, and it is given by Hamilton's, and don't confuse with the Hamiltonian. This is Hamilton's principle. Okay. So what Hamilton does, Hamilton define a mathematical term that is known as what? Action. And what is action? Action is L, and this is function of generalized coordinate, generalized velocity, and time. And this is L dt. What is action? Action is some integral of the time, where L is function of what? Generalized coordinate, generalized velocity, and time. Are you getting my point?
Yes, sir.
Yes. This is action. So particle will follow. So particle will follow only those paths for which action of a system is extremum. पार्टिकल कौन सा पाथ फॉलो करेगा जिसमें एक्शन ऑफ अ सिस्टम क्या हो जाए? एक्सट्रीमम हो जाए. दैट इज व्हाट इज मीनिंग ऑफ दैट? मीनिंग ऑफ दैट del A is equal to del L qi dot t dt must be equal to what? 0. And now we have calculus of variation, isn't it? हमारे पास calculus of variation है ना? Now अभी हमने क्या पढ़ा था? f y dot x dx. If this goes to 0, then f will follow what? D upon dx del f upon del y dot minus del f upon del y is equal to what? 0. F क्या follow कर रहा है? This thing is what? Going to what? 0. Everyone is comfortable?
Yes, sir.
So now you can compare F to L, Y to QI, Y dot to QI dot X to T. So then this L can also will follow Euler-Lagrange equation. Yes? So this can be written as d upon dt and del L upon del QI dot minus del L upon del QI must be equal to 0. And this very famous equation is, now what we want? We want to do physics. We want to analyze our physical system. So what we want? We want this equation must behave like Newton's equation, Newton's law of motion. So हम ये चाहते हैं कि ये जो equation है ये कैसा behave करे? It should behave like Newton's law of motion. Then we try to figure it out. What is this L? L का ऐसा कौन सा form होगा? What will be form of L such that it will behave such like Newton's law of motion? That is, this complete equation must behave Newton's like motion, Newton's law of motion. This is our choice. This is our need. Then we figure it out. If we will take L, which is function of generalized coordinate, generalized velocity, and time is nothing but kinetic energy minus potential energy of a system, then this equation is equivalent to what? Newton's law of motion. And this famous formulation is identified as Lagrangian of a system. Lagrangian of a system. Okay. So this is all about Lagrangian of a system. So Lagrangian of a system is function of generalized coordinate, generalized velocity, and time, and which is equivalent to t minus v. And if this is Lagrangian, then this is equivalent to equation of motion. And this equation of motion is very famously known as Lagrange's equation of motion. क्या कहते हैं इसे? Lagrange's equation of motion. This is very famously known as what? Lagrange's equation of motion. So this is a complete formulation of Lagrangian. We will try to do lot of analysis into next class, and we will straightforward go to different type of problems. Okay? कुछ पूछना है?
Sir, here action means ये जो equation है
LDT. Yes.
इसका कोई physical meaning
नहीं है कोई physical meaning.
Okay, sir.
This is something T minus V. Okay?
Okay, sir.
Okay. So, thank you, students.